Welcome to Cybersecurity Tutorials. This tutorial focuses on behavioral biometrics modalities that can be used for user authentication schemes. Behavioral biometrics offers a simple way to implement frictionless user authentication schemes. Alright, let's begin the tutorial. To authenticate humans, authentication schemes can be categorized as knowledge-based or something you know, for example, PIN, password, or graphical unlock patterns. The second category is token-based or something you have, for example, smart tokens, smart cards, or device pairing. The third category involves biometrics that is something you are. It can be further divided into physiological and behavioral biometrics. Some examples of physiological biometrics are face, fingerprint, hand geometry, and iris. And, some examples of behavioral biometrics are voice, touch strokes, gait, hold, and hand movements. Next, you will learn what is behavioral biometrics and recently researched modalities that are successfully deployed for user authentication for smart devices. Behavioral biometrics deals with human behavioral characteristics or activities pattern that is uniquely identifiable and measurable to generate a classification model that can be used for recognition purposes. Touch stroke, hand movements, swipe, touch signature, voice, single footstep, and gait are some of the behavioral biometrics modalities that are successfully evaluated for user recognition in recent years. Certainly, in the next few years, behavioral biometrics will irrevocably transform the user authentication landscape for IoT applications. Behavioral biometrics can be classified into 5 categories according to the type of information collected from or about the users. The first category is authorship-based biometrics that examines a piece of text or a drawing produced by a person. Verification is done by observing style peculiarities typical to the author of the work being examined, such as the used vocabulary, punctuation or brush strokes. The second category consists of human-computer interaction-based biometrics that leverage input devices, such as touch devices, keyboards, computer mice, and haptics to register inherent, distinctive and consistent muscle actions. It also utilizes advanced human behavior such as strategy, knowledge or skill exhibited by the user during interaction with IoT applications. The third category is closely related to the second category involving indirect human-computer interaction-based biometrics that can be obtained by monitoring users' human-computer interaction behavior indirectly through observable low-level actions of computer software. The fourth category of behavioral biometrics relies on users' motor skills or kinetics for their verification. Motor skill is the ability of a human being to utilize muscles. Muscle movements are the result of the proper functioning of the brain, skeleton, joints, and nervous system. Thus, motor skills indirectly generate a unique identification signature, making person verification possible. The fifth and final category consists of purely behavioral biometrics that measures human behavior, such as the way an individual walk or their hand movements to hold smart devices. Not directly concentrating on measurements of body parts or intrinsic, inimitable and lasting muscle actions. This tutorial explores only to second and fifth categories of behavioral biometrics for user authentication for IoT applications. Touch strokes refer to a user touch sequence upon interacting with touchscreen-based smart devices. It generates a unique digital signature while users navigate a touchscreen with their finger. Features for touchstroke can be divided into 3 categories: timing, spatial, and motion. Some other touch stroke feature are temporal regression forest architecture that registers temporal behavior characteristic of the person when they perform a series of touch strokes continuously, and linear and kernelized dictionaries based on sparse representations to classify the touch stroke. A number of researches have shown that these touch features are discriminative and unique for each individual, thus, may be used as a personal identifier. This tutorial describes 2 types of timing features for touchstroke that can be collected by using inbuilt touch sensors available in smart devices. Here is the first type of touch stroke timing feature that uses dwell and flight time. The dwell time refers to the time duration of a touch event of the same key. Flight time refers to the time interval between the touch events of two successive keys. In slide, you can observe that 30 features are extracted from the 8 touches by a user on the touchscreen. There are 8 type 0 that is dwell time calculation. 7 features of type 1 that are flight time calculation. Similarly, type 2 to type 4 features are computed based on flight timing. The second type of touch stroke timing features that can be extracted with different key touch lengths. The shortest feature length is known as Uni Graph, which is the timing feature extracted by taking the touch event timestamp values of the same key. The timing features extracted from 2, 3 or more keys are called D-graph, tri-graph, and N-graph, respectively. In the next slide, you will learn spatial and motion features for touchstrokes. Spatial features for touchstroke involves physical interactions between a user fingertip and a device touchscreen surface. That can be acquired when a touch event is triggered. The most commonly used spatial features are touch coordinates, touch time, size, and pressure. Similarly, to acquire motion features, motion sensors, such as accelerometer, gyroscope, magnetometer or gravity sensors can be utilized. That is available in most smart devices. Each touch event usually inflicts a small amount of movement or rotation to the device. These motion features can be captured and used to identify a user. However, these motion features can be associated better for other user behaviors. Like hold and pickup motion explained in the next slides. Swipe can be defined as a finite sequence of touch events that occurred as a result of users' interaction on a smart device's touch screen with their finger. Here, spatial features for each touch that can be acquired are the timestamp of touch event, x and y coordinate, velocity and acceleration of the touch points. You can calculate acceleration for each touch point mathematically from velocity data. The touch pressure of each touch point to calculate how hard the finger was pressed on the screen, and size of each touch area. Most of smart devices provide APIs to get touch coordinates, velocity and pressure data for each touch point. Statistical features like min, max, average, standard deviation, and variance can be derived from the velocity, acceleration, and pressure values for all touch sequence data acquired for a swipe action. You can also compute swipe, distance, duration, average touch size, start and end touch points. In the slide, you can observe the statistical swipe features that can be computed, extracted from raw data. Touch signature is the replica of a handwritten signature that allows a person to sign on the smart device's touchscreen by using their finger or stylus. It can be viewed as extended form of swipe gesture, and you can extract the touch features for it that are described in the previous slide. Some more attribute that can be computed for touch signature are touch stroke angles, log curvature radius, stroke length to width ratio. Interested viewer can read the papers indicated in the slide. In the second part of this tutorial, we will describe other behavioral biometrics modalities. Thank you for watching the video. Please subscribe to my channel and like the video.